Oh, sorry, I didn't see that. My name's James Dunn. Good afternoon. I'm here to talk to you today about these little chaps. Do you know what this is? No, of course you don't. This here is a capacitor. A capacitor stores electric charge, so you can let the capacitor charge up quickly and use it to turn a transistor on. We can use a capacitor in a latching circuit, for instance in a burglar alarm, where the warning will stay on even after the problem goes away. A burglar alarm will stay on in response to the sensor until it's been resetted. Capacitors are storage devices which consist of two metal plates, which this little mock-up represents. This is the positive plate. And you see, if we switch the power pack on, the direct current supply, the current will flow, and the plate connected to the negative supply, this black plate here, will absorb electrons. The area of the plates will decide the amount of electrical charge that the capacitor can accept. Electricity is not able to flow between the plates because of the dielectric. The charge stored by the capacitor is measured in farads. Now, there are two completely different kinds of capacitors you need to know about. Firstly, the polarized capacitor, as you've just seen. That's this little fellow here. Now these contain a dielectric, which enables the physical size of the capacitor to be very much reduced. They can be damaged if connected the wrong way around, however. As you can see, there is a long leg and then a much shorter leg, and you need to connect these up correctly as in the circuit. Now, we also have the unpolarized capacitor here. Very nice, this one. You see, this one is used for much smaller values of capacitance and can be connected either way around. Now, we could connect the capacitor directly to, say, the LED in a circuit. However, this is not strictly the best approach, for a resistor will enable the LED, or whatever component it may be in the circuit, to stay on for as long as possible. So we slow down the discharge to the LED to for instance, a 1K resistor might be used here, and a transistor, as direct discharge to the components would be just too quick. Viewers, apologies for that little interjection. Fucking retard. Now, the formula that can be used to work out the time constant for this type of circuit is as follows. T equals R times C. That's T equals R multiplied by C. The units are ohms, farads, and seconds. The time constant gives the time taken to reach 63% of the final voltage level. Now, as we can see, the time constant is measured in seconds. And this equals the resistance of the resistor in ohms multiplied by the capacity of the capacitor in farads. This is an example of one of the resistors that we might use in the circuit. This is a 3K resistor right here, ladies and gentlemen. Here, I should have shown you this earlier, I wish I had. I'm frankly very upset that I didn't. But this is the diagram of the circuit that we would use a capacitor in. This circuit has a LED within it, as you can see here. The switch here. Now, if the circuit is interrupted, a capacitor here will enable us to, well, it will make this a latching circuit, and it will keep the LED on for quite some time because we have a 1K resistor in circuit here. I hope I've answered many, if not all, of your questions on on capacitors. Thank you. Thank you, and good afternoon.